We tend to think of our ears as high-fidelity biological microphones. Sound waves hit the eardrum, the signal travels up the auditory nerve, and the brain simply presses record on physical reality. But that physical recording is heavily edited before you ever consciously hear it. In fact, what you perceive as sound is often an illusion, completely overwritten by what you are looking at. This is a cross-section model of the human inner ear. These structures capture raw acoustic data perfectly, but the brain treats that data as a suggestion rather than a final script. Speech perception is an active construction project where your brain fuses multiple sensory inputs into a single cohesive percept. To understand the voice you actually hear in your head, we have to look past the hardware of the ear and uncover the invisible ways the brain filters and alters the incoming signal. The first layer of cognitive deception is known as the McGurk effect. It reveals exactly how aggressively the brain prioritizes visual cues from a speaker's mouth, even when they contradict the audio. It triggers when you encounter a specific sensory conflict. Imagine listening to a clear audio track of someone saying "ba," but watching a video where their lips form the consonant "ga." Your brain possesses a deep biological aversion to this kind of conflicting data. It evolved to integrate senses for survival, meaning it demands unified resolution between sight and sound. Rather than picking the audio or visual, the ga and ba inputs collide, inventing a new phoneme, da. This bypasses the conscious filter entirely. This integration is mandatory. Even if you know how the illusion works, you cannot stop hearing da. When sight and hearing battle for dominance, your brain acts as a ruthless conflict resolution engine. It would rather completely fabricate a false sound than tolerate a moment of sensory ambiguity. Through phonemic restoration, your brain can generate sound without any visual input at all. It relies on the listener's expectations to fill gaps in the acoustic stream. If a single speech sound is deleted and replaced with a loud noise, like a sudden cough or heavy radio static, the brain interprets the interruption as an external obstacle rather than a break in the speech. Instantly, it scans its internal dictionary and analyzes the surrounding semantic context of the conversation to predict exactly what sound should have been there. The auditory system reconstructs the missing acoustic segment beneath the noise, so the word sounds flawless. But remove the noise and leave pure silence, and the illusion breaks. Without a plausible masker, the reconstruction halts, and the brain detects the missing audio gap. Driven by an evolutionary need to extract coherent meaning from chaotic, noisy environments, your brain functions as an aggressive predictive text engine, physically inventing acoustic data that never existed. This incredible ability to guess and autocorrect keeps us functioning in loud rooms, but it becomes a massive liability the moment you try to learn a new language. In traditional language labs like this one, adults struggle because of the brain's lazy listening habits. When it encounters unfamiliar foreign phonemes, it aggressively autocorrects them, mapping the strange noises directly onto old, familiar native sounds. To actually acquire a second language, you have to break the glitch. This requires perceptual phonetic training, a targeted intervention designed to strip away all the visual cues and contextual crutches your brain relies on. This chart from a recent meta-analysis maps the method's effectiveness. When researchers isolated perceptual phonetic training, it generated a large positive effect size of 0.762 on language competence, massively outperforming other instructional approaches. By forcing learners to process raw, isolated acoustic data, this specific training neutralizes both the bottom-up visual hijacking of the McGurk effect and the top-down hallucinations of phonemic restoration. Our brains are hardwired to bend, blend, and fabricate sensory inputs just to help us survive. But by stripping away our multisensory crutches, we can finally bypass the illusions and force ourselves to listen to the truth.